Okay, so finally I want to look at this boat, but this time I want to change the direction with the rudder, right? So I'm running along this way, right? And I'm going to push the rudder up 30 degrees. And that's going to cause a force. You know, the water is going to push this way, and then it's going to hit this guy and push down that way. So we're going to want to figure out what the force is from turning the rudder 30 degrees. All right, that's all we want to do. What we're going to do for that, you want to do it the other way. What we're going to do for that is we're going to make a triangle, right? So this is 30 degrees. And this is the direction of the rudder. Now, let's see. If the rudder is directly behind us and we're going straight, how much force does it apply? None, right? So that's going to mean, well, I mean, if we just look at the old trigonometry triangle, right? This is 1, then this is going to be sine of 30 degrees, right? This guy's cosine of 30 degrees. And this sine of 30 degrees is going to tell us what proportion of the force is going to turn us, right? And this other proportion of the force is going to slow us down. Okay, so how does that work? So now you're saying, well, if it's 90 degrees, then obviously it's all going to slow us. It's going to slow us down a lot. There's also another thing is that we have to look at the value of the force, and the value of the force is also going to change with direction. So we're not taking into account the value of the force. We're taking that as given as 500 newtons. So, but you know what you're thinking is right. Is that there's another thing here that's coming from the value of the force. So our acceleration here is really just r over m, right? Because, or it's force over m, which is r sine 30 degrees over the mass. Okay, and so r here is going to be 500 newtons. 30 degrees, sine of 30 degrees is 1/2, and the mass is 1,000 kilograms. Okay, so 500 divided by 1,000 is 1/2, and 1/2 times 1/2 is newtons per kilogram, is equal to 1/2 or 1/4 meters per second squared. I wish I had more time so I could actually redo these. So that gives us 1/4 of a meter per second squared for the turning force. This is the force perpendicular to the boat. So we turn this over this way and it's going to produce a force this way, which is 1/4 meters per second squared. And it'll also have a little bit of a force this way, which will be not good. It'll actually slow us down. We can talk about that later if you want. So how did we do this? Well, first we had to figure out the component of the force using trigonometry, because we knew the net or the total value of the force. We only care about but as the rudder is pointing this way and you have different parts of the force pointing in different directions, we only want this part of the force. We don't want this part. So to get rid of this part of the force, we use trigonometry. Okay. After using our trigonometry, then we substituted in some values and did a little math, and then we were done. But we are going to need to use trigonometry a few times when we have two-dimensional motion. All right. So that is Lecture 3. Thank you very much for listening, and I will see you in class. Bye now.